we're moving on to probably, for me, one of the most contentious subjects, which is the foam, firefighting foam, and particularly the PFAS in firefighting foam. And I'm going to ask someone to tell us what PFAS stands for, because I can't remember it. But it's something like poly.
That's easy for you to say, Terry. Yeah.
So basically, it's that horrible forever chemical that stays around. Very emotive subject. I'd love some participation. I know, and Peter is the moderator, very suitably spurred, and he wants to prompt some questions very early on. And we've got a very competent list of panelists as well. So hopefully we'll get some clearance or some good idea into the subject. So Peter, over to you.
Thank you very much, Joe. Are you going to take
oh yeah, I'll sit down. Am I on there, am I? No, I'm not.
Well, thanks very much, Terry, and welcome to the panel. I've just noticed, apart from obviously Terry at the end, most are in alignment with their pictures behind. So we've got Andy, Tomaz, and Evan. Special thanks to Tomaz, because he has stepped in at short notice to cover for David Campbell, who unfortunately had to go off on other business. But again, it's interesting, with the themes that we've been talking about, there is a link between sustainability, the environment, firefighter health and safety, and obviously tackling operationally and extinguishing fires. And some of the things that we will try and cover, because it is quite a deep subject, is looking at best practices, looking at the legislation, local and the rest of the world, the testing of foams, the real world and actual scenario-based, looking at the UL and FM sort of standards, the transition to new foams, because this is quite a big issue. Who takes the responsibility and at what time, etc., does it come in? And looking at the process, the application, the rates and flows, equipment, storage, type of attack, and quality of water. I'm going to start off, we had a little discussion earlier, foam concentrate doesn't put out fires. That's one that Andy mentioned earlier. I actually quite like that. So I'm going to start off and dive in with Andy. Mm-hmm. Why are we here discussing PFAS?
Right. Okay. We could spend all afternoon just trying to pronounce per and polyperfluoroalkyl substances.
Well done.
But I did practice this morning and brushed my teeth as well. We already talked about asbestos this morning. We could have added to that halon, and of course I'm old enough to have been involved in the halon replacement. PFAS comes into the same consideration. It adds, well, some of the fluorosurfactants add some particularly positive capabilities to the firefighting foam we've used over the last 50 years. But starting in 2000, we identified a member of the PFAS family, which has got some questionable characteristics in terms of toxicity, bioaccumulation, and persistence. Since then, we've started looking at the expanded family. PFASs are man-made substances, they don't occur in nature, and we're starting to determine that they're substances that we want to restrict, stop, and ban. And we've identified currently over 11,000 different PFASs. So bottom line, it's been determined that although firefighting foam represents a very small percentage, of course they are highly emissive, because when we utilize them, they're very hard to contain. We don't determine where that truck turns over at Satwa roundabout. Well, maybe Satwa's not a good example anymore, but and then of course we trained with them for many, many years.
Mm-hmm. Thank you. Moving on to maybe sort of a little bit of the testing side, because we've got two experts on that sphere. You've got the UL, you've got the FM, and other tests. I think within the industry, you can get the pass or fail, but is it really representative of a real scenario? Maybe, Evan?
Well, when it comes to testing, UL and FM is a good example of tests and listings we want to do, because they are linking hardware with our foam concentrate to give us a foam we know can put a fire out if we pass the test. There are other standards which in the past have been good enough, because with AFFFs and AR-AFFFs, they contain fluorine, and with fluorine we've had the sort of a safety factor, I would say, because you know that when you put the foam on a fire, it more or less puts the fire out anyway. And that was the old thinking. I mean, it's been a long time since we at Fomtech thought like that, because we know that we want to push data, not opinions. We don't want to go into someone and say, it'll probably put the fire out, because we want to make sure that our product works when we put it into an industry. So with respects to that, UL and FM is the standards we follow closely now, because we can link all hardware when it comes to the storing of the foam, the proportioning of the foam. We know that it can create the premix that we want. When it reaches the discharge device, be it a monitor or a sprinkler or even a grate nozzle, we know that with all the hardware we have in our listing, the product will perform. And that's why we want to have that approach.
Okay, thank you. And Thomas, maybe with from the end user's point of view, with the testing and the knowledge with foams, how do they pick the best foam?
Important here to mention, from the conformity assessment point of view, both certification bodies and testing laboratories are having tools in hand to provide evaluation of the performance of foams. Worthy to know, and it's even at this stage, regardless of whether they contain or they do not contain fluorinated substances. Historically, firefighting foams were developed in experimental works, and where technology was quite mature, we may say. The aspects of the foam extinguishment performance were not, I would say, described in first principles. Therefore, fire protection industry relies heavily on approval tests, and thanks to those aspects which are achieved in the fire test, in the fire test approval tests, the capability of the foam can be determined, and further it can be extrapolated to the final end use, expected end use. And here is where we see that there are standards. So those tools which I meant and those approval methods are described in standards. We have UL 162 or FM 5130, and these are, I call it American-based standards, and these standards are referred in the local regulations. So these are those who may be familiar while working on the projects. On the other hand, there is also, I can call it counterpart of array of standards for foam concentrates in Europe. This is a series of standards, EN 1568, parts from 1 to 4, dealing with various concentrates, medium, high, low expansion foam, and then alcohol resistance. Plus, there is also an aspect of hardware, this equipment which is used to generate the foam, and this is the other standard, EN 13565 part 1, which is supported also by part 2 for the design of the products. However, as I mentioned, here regionally, both UL and FM are recognized. We can focus on these differences maybe when there will be some questions regarding that part. But most important, FM and UL focus not only, standards focus not only on the concentrate alone, but also the equipment to generate the final product which we need, which is the foam, foam with the proper structure, proper quality. So these are, I believe, the main gains for the market, where the information which is coming from the actual testing, in a scale which shows what's in the end is produced, can help to further properly address the hazards, the risks which are on site to be protected.
I think, Andy, you maybe wanted to respond there. I could see you itching at the end.
I just wanted to add a little bit there. You know, effectively, we were dealing with, and whether you call it a formulation or a technology that was in place for 50 years. And a lot of the test standards, the performance fire tests, were developed around the knowledge of what that technology could do. With taking the fluorosurfactants and fluoropolymers out of the foam concentrates, we're really dealing with a new technology, and we're finding already that some of the standards are now evolving to embrace the capabilities of the fluorine-free foam. And I'll give two examples. FM has already said that you can't just use heptane as covering all hydrocarbon fuels. That's in the 5130 standard from last year. UL in the last 6 months, sorry, it's all foam nerdy stuff, I'm afraid. With the UL 162 topside test, you had a direct impingement, a type 3 application. And if you passed the type 3 application, they automatically gave you a type 2 because it was assumed that a gentle application was easier than a forceful. UL has now changed that you actually have to also do a type 2 application because they recognize that fluorine-free foams don't behave the same way as fluorinated. So there is a real case now that the environmental legislation has come in before the industry is fully ready to embrace the changes. So we're playing catch up.
Yeah. So on that point, would you change today to fluorine-free?
Would I?
Yeah.
Absolutely.
Yeah.
But I think, I've been talking about fluorine-free foams for more than 10 years. What we're seeing is that you have to understand that it doesn't behave the same way. But as an engineer, if you understand the limitations and you understand what's required, and that might be, you go back to a hazard analysis and you tackle even a transition as a new project, that may require changes in hardware. It may require changes in application density. It may require changes, and I stress this for the emergency response firefighting. We may have to go back to training people again, which we haven't done for 10 years or more. But we can solve the problem.
Yeah, I think that's one for Terry there, operationally.
Thank you very much for the descriptions that you've mentioned, and it's all very true, of course. The thing I'd like to point out is foam testing has to be relative to scale. I mean, we're talking now surely about tier 1 facilities, okay? Automatic systems that are sitting on facilities ready to have a rapid knockdown, for example, a rim seal protection system or whatever. We're certainly not talking about full surface spread because there has never, ever been a successful extinguishment of a full surface fire, I can guarantee it. And there's not even a test facility that can prove that. So let's put it to scale and say, right, we're talking about tier 1, which I accept, but Andy started the conversation saying the foam has changed, it's completely changed its makeup, which is true, because the polymer is no longer there. The polymer is what has always been the success rate of foam, because that basically seals the fuel, and then you're able to put foam on the top of the polymer. That's missing. So the 162 test is a 7-meter diameter, a 7-meter tray of fuel with a 3-minute pre-burn, but it does not reflect in the real conditions of a storage tank or any industrial situation where you've got thermal energy traveling through the fuel, you've got all sorts of wind conditions. It's usually in a confined area. So, you know, let's be perfectly frank about it. If industry is expecting us to transition, then yes, we need to see the full picture, not just some glossy brochures that are saying we've got PFAS-free foam and it works exactly the same. Number one, you've already told us that we may have to re-engineer our systems. That's massive for you know, oil and gas companies. That's massive. That, you know, you've got to start re-engineering fire systems that have been there for the past 15, 20 years. You know, okay, you may argue, well, oil companies can afford to do that. Well, maybe they can and maybe they can't, but I won't go into the economies of scale, but we will all pay for it at the end of the day, so don't worry about that. I'm just ask one point, if I can just go on to the second one. The EU, is it 1368, yeah? 1368?
1568.
1568. So there's an interesting test regime with EU standards. And a lot of companies are using EU as a reference, by the way. And I argue on 2 points. First of all, the EU standard, the conditions there, the environmental situation is nothing like we've got here. We have ambient temperatures of 45 plus. EU, we would all be dead if it had 45 degrees in the EU. So that doesn't reflect that. Plus, there are levels of pass and fail. So you've got, good extinguishment or not. And in the case of most PFAS-free foams, it's not been a good extinguishment. It's either a 1 or a 2, and it should be a 0, or the other way around. I'm not a boffin, but anyway, it's certainly, for me, it's not a pass. It should be highest level of pass every time. Certainly for tier 1. You expect that to be rapid knockdown. And secondly, the other area was what do they call it when the foam stays solid?
Burn back.
Burn back.
Resistance.
So burn back should be also a very high level, particularly on rim seal sort of protection. Let's not talk about, we're getting all oil and gas here, but I don't want to do that. But you know, I'm not talking about bund or dike, whatever you use as a reference. That's something else. That's something probably easy because it's a spillage. I'm talking about a live situation on a tank. So burn back would be critical. You need it to be sealed. So, yeah, a big subject. Excuse me for putting those roadblocks in, but I think it's important that we, open up. We have some experts also on the floor.
Yeah, I think we'll get some questions now, actually, because
yeah,
I think, having the knowledge that's come, Terry, operationally, it's good to have all these little things come forward. We were looking for questions a bit earlier. We're down to 3 minutes left. So, Kevin, we've got a question over there.
We can extend. I'm in charge.
Yeah, hi. Kevin Whitehead, Unity Fire and Safety. Also a member of the IPEN committee advisor to the Stockholm Convention. The UAE and most of the other GCC countries are signatories to the Stockholm Convention. And I think the UAE signed in around about 2005, if I'm correct. PFAS is listed within Annex A of the Stockholm Convention, which means it is a global legislation. So, Terry, to correct you, it's not the manufacturers who are forcing change. This is international legislation. So the international legislation is forcing the change, and the manufacturers are reacting to the legislation to provide something which should perform the same, but also protect the environment, and importantly, people. So PFAS, globally published information, causes leukemia, fetal development problems, kidney cancer, allergies, etc. This is not a good product. So it's not about the manufacturers forcing change. Right? This is international legislation. And as I say, Anybody, any organisation, any country that's signed up to the Stockholm Convention is legally obliged to eliminate and remove PFAS. Thanks.
Can I make a comment on that? I know it's not a good thing to correct people, but PFAS, as I mentioned before, covers over 11,000 chemicals. Yeah. The Stockholm Convention currently covers PFAS, which is unidentified, and in 2019, the substance PFOA was added to the Stockholm Convention. So it's, sorry for letting me, PFAS as a collective of compounds is not covered by the Stockholm Convention. PFOS and PFOA, which are substances which, PFOS was found in 3M light water products. PFOA is found as a precursor in the C8 and longer chain foams manufactured by the other manufacturers up until 2016. So forgive me for correcting. I'm not disagreeing. Trust me. I am totally about changing to fluorine-free foam. I just like to do it from a position that is based on data.
No, thank you for that. We're actually spot on time now.
We can carry on.
If you want to carry on, because I think that's really good brought up some good debate. So if there's any more questions...
I think there's a lot more to come.
Yeah.
So we're okay, yeah? Let's have a vote. All those in favour say aye. The ayes have it.
So where's the next question?
No questions.
Go on. Thank you.
You don't need a mic.
So true. Andy, I was very interested in what you said, sir, and I'd like to know a little bit more from someone who works in the training academy. You mentioned that to use the fluorine-free foams that we might have to go back to training, and it behaves differently. Can you expand on that for me, please? And what kind of training and what kind of characteristics should we expect?
I think part of the issue, foam, because of its persistent biotox, PBT characteristics, one of the things that happened, particularly in aviation and military, was we stopped training with it, municipals as well. And I'm going to say 10 to 12 years ago, probably, again, when PFOS was made a POP, which is 2009, so that's 14 years. What's been found in evaluation work by people like the NFPA Research Association, the DoD in the US with the work they've done on their mil spec, and also by people like Lastfire, is that it does behave differently. And those of you that are old enough, we're now relying, as we used to do back with pure protein, on bubble structure. With AFFF, we could pretty much aim at the target, get it, and what I used to call chase the flames. If you do that with a fluorine-free foam, you will not be as efficient, because we want to get back to building a blanket and moving it across. And we don't chase the flames. So that's why I said there are some of us in here that probably did that handheld work with protein foam and will understand what I'm saying. But most of our younger firefighters have only ever known AFFF or ARAFFF. So, with any product, to make people efficient, you have to train with it, which is going to make me the most unpopular person. Well, it does, because that's part of my line. When I talk to the aviation industry particularly, that has totally gone propane with water. That does not simulate utilizing firefighting foam.
Fair comment.
Now, when you mentioned light water, I had a little flashback to my operational days, and I think it was 1985, Bob, you'll probably remember. We took on AFFF onto the water tenders to operate through the hose reels. And at the time, it was very good for cleaning your leggings and all that sort of thing. And no one really sort of saw any hazard risk around it? It was just one of those things, you'd slop it around, etc. Has that mindset now changed where people do treat it with the respect it deserves?
Who wants to step in here? Because I feel like I'm dominating this one.
I could see Terry was mulling that one over there.
I think, an operation on Terry is a lot more experience. I obviously, most of mine is from a manufacturer and product presentations and training. We didn't think about it. Certainly PFAS, has been identified as a potential, and there are litigation cases ongoing in the US from firefighters in military and aviation where they trained consistently against products that contained PFAS. I think from 2009, the word went out, foam, we should not be using it in training. And since then we've gone to things like training foam, which again is basic. It doesn't have fluorosurfactants in it. In effect, it is a type of fluorine-free foam. Or people have gone to simulation, propane gas using water, and again, you're seeing more and more now video simulation used as well. I'm old school enough that I think it has a value, but it shouldn't be the only tool. Firefighters need to experience the heat and the stress of fighting real fires.
Terry, do you want to, you seem to be mulling that one over.
No, I concur with Andy. I mean, basically, there are so many, sad stories that have been brought, to the attention of the fire and rescue family that people now are a little bit guarded as to what they're going to do with this foam. Like we used to be, like you mentioned, we were very blasé about it, but it's absolutely documented that there are serious cancer implications, and that's getting away from the forever chemical that is going into the food chain, which that's affecting non-firefighting personnel. So people are becoming more aware of it, and it's a big subject, and we could go on for quite some time with it. But I'm sure you're probably fed up with it by now.
Should we wrap up then and
yeah,
move on?
we certainly can.
Well,
yeah, thank you.
Just put our hands together for the panel. Thank you very much.